Hi, this is Zabro and welcome to my channel. Today we are going to start another new topic, that is internal combustion engine. So internal combustion engine, what is the internal combustion engine? That engine where the combustion happens to provide the rotating motion of any wheel which is connected with that engine. So we can take an example of a motorbike. So we are seeing that the motorbike is running. So how the motorbike runs? So there is a combustion going on inside the motorbike engine, so which makes the wheel rotate as per the speed we give, we make the motorcycle to run. So here we have one internal combustion engine, one schematic diagram, how the internal combustion engine works. So we can take think that this wheel is a wheel of a motorbike, which makes the bike to move as the bike. The wheel is moving, and it moves when we put the petrol inside the bike, so the combustion takes place, and which makes the wheel to rotate with the help of the connecting rod or camshaft, and which helps the bike to move forward with a specific speed. So here I can give the example, the description of an internal combustion engine, this entire diagram. So I will start from the beginning. This is an air cleaner where the air, all the dust particles, it prevents the dust particle to enter into through the petrol or the diesel which is being injected into the internal combustion engine. So because if the dart particle goes, sometimes there may not be the proper combustion, or there may be the incomplete combustion of the fuel, which may not help the wheel of the motorbike to rotate, and the motorbike will not be able to go forward. So this is the carburetor. Through this the fuel is injected. This is the rocker arm. This is one part. This is the spark plug, and this is the cylindrical block, and this is the main thing. This is place is the combustion chamber where the combustion of the fuel takes place, or the petrol or the fuel takes place. With the presence of oxygen, the combustion of the fuel takes place over here. And this is the piston, this is the connecting rod, this is the camshaft, this is the flywheel, this area, this is the flywheel, and this is the oil stick. So this is the oil stick, and this is the connecting rod, and this is, you can say, this is the fuel. So this helps here the combustion takes place, and this is the piston where which helps the connecting rod and the camshaft or the flywheel or the brake drum to rotate about its own axis, and ultimately if it rotates, then it will help the motorbike to go forward. So this is the, and this is the spark plug. When the combustion takes place, the sparking takes place, so it will help the spark, it will means try to keep the sparking within the limit, so that if there may be the excessive sparking which may lead to the damage of the engine, so the sparking plug is there. This is the cylinder block, this is the tappet. So this is the engine, that is where the combustion of the fuel with oxygen takes place in the combustion space. So here we go with one of the numerical of the internal combustion engine, that is engine with 90% mechanical efficiency has rating of 38 kilowatt brake power. Estimate its indicated power and frictional power loss. Also determine the mechanical efficiency at quarter load, assuming frictional power to remain same. So here we have got the data, that is the mechanical efficiency is 90%, and the this engine 90% mechanical efficiency rating is 38 kilowatt, that is the brake power. So we have to find the indicated power and the frictional power loss, and we have to also determine the mechanical efficiency at the quarter load. So we have to always memorize the formula. So in what situation what formula should be used to take out the correct answer. So we have already got the efficiency is 90%. So we always know the efficiency is equal to output by input. So output by input, if we have to, if we can, if we need to take out the indicated power, so brake power divided by mechanical efficiency, we have to divide. So because we know that efficiency is equal to output, this is the output divided by input. So output divided by input is always the efficiency. So the indicated power will be, if we divide it by 0.9, so the indicated power is 42.2 kilowatt or 42.22 kilowatt. So this is the first answer. Now what is the second part? That is the frictional power loss. So what is the loss? That is the indicated power minus brake power. It is similar to the electrical machines where there are many type of losses like friction loss, windage loss, copper loss. So we always try to deduct the loss from the means input to get the output. So if we know the system, there is a input. So in the system there will be always the losses, and ultimately we'll get the output from the input. So there will be many loss in this system. So if there are many losses in the system, so that we have to input minus loss, that is the input minus loss is equal to output. So here is the same concept used over here, that is indicated power minus brake power, that is 42.22 minus 38, that is 4.22 kilowatt. So this is the frictional power loss. So now we will take out the brake power at the quarter load, that is 0.25 into 38. So this 0.25 and 38 is nothing but the brake power, that is 38 kilowatt, and 0.25 we are multiplying to get the brake power at the quarter load. Quarter means nothing by 1 by 4, and if it is told the brake power at half load, then we would have multiplied into 0.5. So it is 9.5 kilowatt. Now it is the mechanical efficiency, that is the brake power divided by the indicated power. The brake power is 9.5, that we have already calculated over here, divided by indicated power, that is 9.5 plus 4.22. 4.22 is the 4.22 we have already calculated over here. That is the frictional power loss, and indicated power is 9.5. So we are adding these two, and we are making this 9.5 divided by, so 9.5 plus 4.2, so we can just give an estimate, that will be 13.72. So if we just calculate with multiply to 100, we'll get the answer 69.24. So this is the final answer. So I hope you have understood how the motorbike runs, what is called the combustion, internal combustion engine, where the combustion is taken place inside the engine when the fuel is injected into the engine, and the fuel is reacting with the air, and the combustion is taking place, which helps the wheel to rotate, and which makes the vehicle or the motorbike to go forward with a certain speed. And here we have also about how we have calculated the mechanical efficiency, brake power, frictional loss, as well as the indicated power of that engine. So I hope this video was very interesting, and we will go forward with the next video with the new topics. Thank you very much.